Let's move on to coordinate proofs. Now, coordinate proofs are, we treat those a little bit more informally, and what we usually use is the coordinate grid and the locations of the corners of a quadrilateral in order to prove that something is a certain length or something is a certain shape. Quick review of the things you're going to need. We're going to start out with the distance formula. Distance formula, as I like to define it, is just a variation of the Pythagorean theorem, which is a squared plus b squared equals c squared. If you take the square root of both sides of the Pythagorean theorem, you have c is equal to the square root of a squared plus b squared. And now what we're really talking about here is the square root of your change in x, so difference of x's squared plus the difference of y squared. So you take your y's and subtract them, and that's going to be equal to your distance. Remember, distance is always a single number. Don't get 2 points or don't have a comma in your distance. A distance is always one number. Midpoint, on the other hand, is the average of the x's and the average of the y's separately. So it is two numbers. Midpoint is always going to come out as two numbers. And the midpoint formula says you're going to get coordinates, and you're going to take the average of your two x values, comma, the average of your two y values. So average of your x, average of your y's, or just the number in the middle. And then finally, slope formula is again going to go back to the differences between the x's and differences in the y. But slope, usually abbreviated m, is going to be rise over run, which means difference in y's over the difference in the x's. So if you're already taking your difference in y's and difference of x's for your distance formula, you get to reuse them in your slope. Put the difference in the y's on top, differences in x in bottom. You may also see this written like this if you feel more comfortable with this form. So you want to use these three basic tools, slope, distance, and midpoint, to do your coordinate proofs. And that should be enough information to solve pretty much anything. So in this first example, it says, what is the length of the mid-segment? Well, the length of the mid-segment is going to be the average of the lengths of the bottom and the top. We can see here that our y value never changes, our height never changes here. That means that all we actually have to do, we can take a little shortcut, is subtract those two values. So if the difference in one coordinate is 0, the difference in the other one is 9. I'll plug it in the distance formula just to prove that your distance is going to be 9. But you have the square root of 9 squared plus 0 squared. And if 9 squared is 81, 0 squared is 0, so the square root of 81, and that's going to equal 9. Could have told you that just knowing that the other one is 0, we're going to get our 9. On the bottom, same trick. We have a difference of 0 between our y's, but a difference of 20 here between our x's. So our distance here is 20. The average of 9 and 20 is going to be the length of our mid-segment. So let's average those two, add them together, divide by 2. 29 over 2 comes out to 14.5. So the length of our mid-segment is going to be 14.5.